When it comes to multiplying and dividing rational expressions, it's kind of fun. Basically, all you're going to do is factor each of the corners, so to speak, of the problem. In the top left, I can factor out a 2 and have p minus 2. On the bottom right, I can factor out an 8 and have p minus 2 left over. Then, after each corner of this problem is factored, then we can start to cancel. I notice the parentheses of p minus 2's are canceled, and by the way, we can only cancel across a multiplication sign. I notice that the 2 cancels with the 8 down the bottom right, leaving a 1 and a 4. So basically that top left is all finished. The 4 that's down in the bottom right can cancel with a 4 that's directly above it, so that's all gone. And then we have a p squared and a p. I can cancel the p with the p squared, leaving a p. And all that's left down on the bottom there is a 6. So our final answer is p over 6. It's very common for students to accidentally leave a certain part of their answer out because they didn't see what was left. So this might be a place where I could recommend the scribble out method, because that way after you've finished scribbling out, you're pretty darn sure what you're left with. However, then you can't go back and rework your problem because you can't see it all the time. So you have to judge for yourself. If you find that you're missing out terms in your work, not carrying them through to your answer, then I would suggest scribbling things out. If you're doing just fine with just simple crossing things out, I'd go with that right there. Okay, in this next problem, the division is written as one fraction divided by another. And you know, whenever you divide fractions, you multiply by the reciprocal. So that numerator factors into p minus 2 times p minus 4, and that's over 24. And I'm going to turn that division into multiplication by the reciprocal of the next fraction. So that 6 times p, or 6p plus 6, I'm going to move up to the numerator, 6 times p plus 1, factoring as I go. And the 16 minus p squared, which is in the numerator, now comes down to the denominator and becomes 4 plus p times 4 minus p. Now we have a problem like the one above, and it's already factored. Now, the p minus 4 and the 4 minus p are almost cancelable if we use the -1 technique and let either the numerator or the denominator become a -1. We can also cancel the 24 with the 6, giving us a 1 and a 4. Notice something else I did. Notice how I had forward cancels and backwards cancels, cancellation marks. That's something I've developed over the years so I can tell or identify what has been canceled with what. All I see left in this problem is negative upstairs times p minus 2 times p plus 1 over 4 times the quantity, 4 plus p, which I'm going to rearrange to p plus 4. Addition is commutative, and I can rearrange that, but we've got to be careful not to reverse the order of subtraction. Okay, number 3, just a pretty straightforward problem. Let's factor each corner. Up in the numerator, I can divide out a 6, leaving me with a minus 1. Up in the top right, I can factor out an a and have a plus 5 left over. In the bottom left, nothing, no GCF, but I can factor that into a plus 5 times a plus 1. And I'm going to rewrite my 12a down below, even though it doesn't factor, so I can kind of just move it out. It looks better that way. Okay, I can cancel a plus 5's on one diagonal. Don't forget to put the 1's there. A's, top to bottom in that second fraction, are cancelable. And finally, the 12 and the 6 leaves us with a 2 down in the denominator. So we are left up in the numerator with only the a minus 1, so no parentheses are needed anymore. And down below, 2 times the quantity a plus 1. And that would be our answer. Now, number 4 here. We know that division we can't cancel across it, but if I turn it into multiplication and I flip that second fraction over, what I like to do is factor in place. Up on the top left, I'm going to have x minus 2y times x plus y, and you'll notice I'm factoring pretty quickly because the emphasis here is on the division problem, not on do you know how to factor. Down here in the bottom left, no change. I'm just going to bring my x plus 2y down. When I factor this denominator, I'm going to move the factored form up top. We have the difference of two squares, x plus 2y times x minus 2y. And the second numerator becomes the denominator, and we get two parentheses, each with an x minus 2y in it. And if you need to pause and check my factoring, go for it. I see an x plus 2y in the bottom left, canceling with an x plus 2y in the top right. I see an x minus 2y up on the top left, canceling with one of the x minus 2y's down on the bottom right. And straight up and down in that second fraction, there's another factor of x minus 2y's that cancel. All that's left in this problem is x plus y all over 1. So just x plus y by itself. If everything had canceled out, our final answer would not be 0. Our final answer would have been 1, because you're not canceling, subtracting things away into zeroness, but you're dividing out and getting ones. Like zeroness is really a word. Okay, there we go for this section.